Hello, it is and receiving students. Thank you. Sit down. Class, in our previous lesson, who can tell me what we have learned? In our previous lesson. Mark.
Relationship of interior and exterior angles.
Very good. Relationship of interior and exterior angles. Okay. That was the lesson that we have looked at in our previous lesson. Now, during that lesson, we had a triangle shape. We said that the interior angles of a triangle adds up to 180 degrees. What about the exterior angles? They also add up to 180 degrees. So in order for you to find a value of an exterior angle, you are going to add the sum of the two interior angles plus the opposite angle of the interior angle to get a angle sum of a exterior angle. Now, in today's lesson, we are going to look at the sum of interior angles of polygons. Again, we're going to look at the sum of interior angles of polygons. Class, do you all know what polygons are? Polygon shapes? Okay. Philippa, would you give me one of a shape that is a polygon?
Quadrilateral.
Quadrilateral, yes. Quadrilateral shapes are known as polygons. What are the others? What are the others? Our friend at the back. You. Daniel.
Pentagon.
Pentagon. Class, is it correct? Pentagon? Very good. Some more. A common one that you all know. A common shape. A common shape. Yes.
Triangle.
Triangle. Very good. Now, there are so many polygons that you can name. But the common ones are like triangle, pentagon, and quadrilateral shapes. Quadrilateral shapes includes square, rectangles. Now, on the screen, I have some of the examples. A triangle shape, quadrilateral, pentagon, and hexagon. Now, we are going to find the interior angles of these polygons. The question here is, how can we find the interior angles of polygons? Okay, we have looked at finding out interior angles of a triangle and also the exterior angles of a triangle. Now, class, a polygon is a figure with straight sides. Okay, those are known as polygons, and we are going to find out the sum of the interior angles of a polygon. To help us to find out the sum of the interior angles of a polygon, we're going to look at the common shape that we have seen in our previous lessons. Class, what is that shape? Triangle. What did we say the angle sum of a triangle is? 180 degrees. To find an angle sum of a triangle, you are going to add all the sides, all the angles inside the triangle. A triangle has how many sides? Three sides. Okay, so therefore it has three angles. Now, class, to find the interior angle sum of a polygon, It is based on the number of internal triangles. Again, to find a interior angle sum of a polygon, any polygon, it depends on the number of triangles in that polygon. For example, one common polygon that we all know of is a triangle. How many triangles can you see here, class? One. Okay, good. One triangle. Ever look at the quadrilateral? How many triangles can you see in a quadrilateral? Two. Are you sure? Yes. Okay, good. There are two triangles. Okay? How many triangles in a pentagon? Three. Okay, good. Three triangles. How many triangles in a hexagon? Four. Okay, four triangles. Very good. Now, I've got an activity for us to do. On the screen and also in your activity book, you will see that you will see a table showing like this. It has three columns. First column, it says the number of sides of that polygon. Okay, the second column, the number of triangles formed. The third column, angle sum of polygons. Below each column, each row has a question mark. Now, we are going to find what is missing in those spaces. Okay, the number of sides of a polygon, which is number three sides of a polygon. What sort of shape is that? What sort of polygon is that when that polygon has three sides? What is the name of that polygon? Huh? Triangle. Very good. It's a triangle. A triangle has how many sides? Three sides. Now, to find the number of triangles formed, how many triangles formed in a triangle? One. We said one. Very good. Now, the angle sum of the polygon. How much? 180 degrees. So, to find the angle sum of a polygon, especially triangle, this is how you are going to work it out. 1 times 180 degrees is equals to 180 degrees. 1 represents what? The number of triangles, and the 180 degrees represents the sum of the triangle, which is 180 degrees. So we know that the angle sum of a polygon called triangle is 180 degrees. Good. Now, next. A polygon which has four sides. What is the name of that polygon? Class? Eddie, what is the name of that polygon?
Quadrilateral.
Quadrilateral. Class, is E correct? Okay, very good. Quadrilateral. How many triangles does it form? Okay, two triangles. Now, the angle sum of polygons. Who would like to give the angle sum of a polygon called quadrilateral? What do you think? Who would like to give the angle sum of the quadrilateral? Angle sum of a quadrilateral. Philippa, what is the angle sum of a quadrilateral?
By times in 2 times 180, which will give you 360 degrees.
Again?
Times 2 times 180 degrees to give you 360 degrees.
Can you come and show it on the whiteboard? The others watching? Class, receiving students, do you think she is correct by saying the angle sum of a quadrilateral is 360? Is she correct? Yes. Very good. So the number of triangles formed is 2, and the 180 degrees represents the angle sum of a triangle. So there are how many triangles in a quadrilateral? 2 triangles. So you multiply 2 times 180 degrees, that will give you 360 degrees. Okay. Now, so as you can see the table, when you have the number of sides of a polygon, you're going to look at the number of triangles that polygon has, and then to find the angle sum of a polygon, you multiply the number of triangles formed by the angle sum of a triangle. Okay? Now we're going to do our activity to help us to understand more on how to find the angle sum of a polygon. To the receiving teacher, in this lesson I am going to use the strategy called workstations. Okay? I've got 5 groups, and each group has a activity to do. So the students will be moving from one group to another to do each activity. You can divide your students into groups and apply this same strategy. This is how you are going to do the activity. Okay, I will give you 4 minutes to look at one activity which is on your table. As soon as 4 minutes is up, first group will move to the second group, and the second group you move to third group you move to the fourth group, and fifth group, where you're going to move to? The first group. Okay, you are the fifth group, you're going to move to the second group. Is that clear, class? Okay, do you know what to do? You are going to read the questions and answer the questions in a group. The answer should come from the group, not only one person giving the answer. Everybody, you contribute how you understand each question in that particular workstation. With that, let us start. As soon as the time is up, you move. Okay, you can start now. sides, yeah? So if the number of sides is 2, then you use this formula here. Yeah, this one. Okay, time is up. Move to the next group. As soon as you reach the other group, you sit down and start working on the second question. Okay, settle down, you can start. Sides. Time is up. Move to the next workstation. Okay, settle down and start looking at the question. Make sure you discuss the question with your friends and you come up with an answer. question 1. Finish there. Make sure all of the group members have the same answer. Okay? If you all agree on one answer, then everybody has to put down that answer. You know these regular polygons like pentagon, octagon, decagon. Pentagon, how many sides? N refers to the number of sides. So if n is 3 sides, you thinking? Okay. Like for example, n is any number. Okay.
N stands for number.
A number, yeah. It can be 2, it can be 1. You can imagine that now. So if n represents 5, then how many triangles? 4. How many triangles? 2. So angle sum of a polygon is? You see? So if n represents 3, it's number of sides. How many triangles? Something like that, you see? So if n represents 10, then how many triangles form? Okay? Well, you have to draw it and then you divide it up to find out the triangles. Okay, move to the next group. Time is up. Sit down and start working on your questions. Class, I believe you should have at least looked at all the questions, the 5 questions. So now you can move back to your own group. Okay, class, to the resident teacher, the exercise that we have done is been taken out from the textbook, 8A textbook, page 120. So if you don't have any worksheets available, you can check the 8A textbook, page 120, and can give the activities to your students. Class, we are going to correct exercise 5 first, and the rest we'll correct it later on. To the receiving teacher, you can collect the workbooks and check all the answers of each of the students. Now, 8 is, which group would like to do exercise number 5 on the board and explain their working out and how they happen to get the answer? Exercise 5 is asking you to find the size of each angle in A. A regular pentagon, B. A regular octagon, B. C. A regular decagon. You're going to find the size of each angle in, or angle sum of each polygons there. A. Okay, group 3. Group 3, you. Any member, you come up and write your answer for A regular pentagon, and explain how you got the angle sum of the pentagon. Show your working out as well. And group number 5. Group number 5 at the back. You have a presenter for letter B. And group number 2, you have a presenter for letter C. Philippa and your group. Okay, class, sit up straight. Let's hear from our friend.
This is how we got our answer. We used the formula S equals to n take away 2 times 180 degrees. To find the size of each angle in a regular pentagon, first we looked at the number of sides, which is 5. Then we minus 2 by 5, which we got 3. Multiplied 3 by 180 degrees, which gave us 540 degrees over 5. 5 meaning the number of sides. Then we divide it and got our answer, 180 degrees.
Okay, thank you. Group A. Who has got a different answer to group number 3 for letter A? All got the same answer? All got the same answer? Who has got a different working out but came up with the same answer? Which group? All of you got the same working out? Okay. Now, class, look up here. The formula S is equals to, in brackets, n minus 2, in brackets, times 180 degrees. S represents the the sum of a polygon, and represents the number of sides of that polygon, and then times by 180 degrees. So, A is asking for a regular pentagon. How many sides does a regular pentagon have? 5. So 5 goes in place where letter N is. So 5 minus 2 is equals to 3. So 3 times 180 degrees is equals to 540 degrees. So is this answer correct? Is this answer correct? Yes. Okay, very good. Now, a regular octagon. Regular octagon, group number. Which group did I ask to come and present? Okay, the last group. Come, quickly. I'll have your formula on the board. You just show you're working out. To the side.
For B, the polygon was an octagon. It had 8 sides, so we put S equals n minus 2 times 180. N, 8 minus 2 gave us 6. 6 times 180 degrees equals to 1080, and then 1080 divided by the sides of the octagon, which was 8 sides, gave us 135 degrees.
Very good. Give a 5 big claps. Okay, the last group. Let us say. The last group. Okay, class, all look up on the board. Let's work it out together on the board. How many sides does a decagon have? 10. Are you sure? Yes. Okay, so S is equals to 10 minus 2 times 180 degrees. Good. 10 minus 2, 8 times 180 degrees. So 8 times 180 is equals to 1440 degrees divided by 10. Okay, so our answer is cancel, so 144 degrees. That's for decagon. Is that clear? Yes. Okay. Class, the summary for today's lesson is to find the angle sum of a polygon. You use the formula S in brackets n minus 2 times 180 degrees to find the angle sum of any polygons. Is that clear? Letter S represents the sum of the sum of polygon, okay, and n represents number of sides, minus 2 times 180 degrees. With that, our key phrase for today's lesson is sum of interior angles of polygons. To the receiving teacher for lesson topic on making solids, you have to prepare these following materials: pencil, A4 papers, scissors, curtains, boxes, cardboards, or rulers. We are going to go into a new substrand on nets. With that, thank you all for participating in the lesson.